Hello friends, welcome again. This time I am here with you with a very unique problem of probability. I hope you would have neither faced this type of problem. The problem is a box contains 2 white and 3 black balls. A, B, C and D, these are the names of persons. A, B, C and D respectively draw one ball in turn. That means first A takes, then B, then C and at last D takes a ball without replacement. Yes, this is the case of probability without replacement. The ball drawn by A is not replaced. The ball drawn by B is also not replaced. The ball drawn by C is also not replaced, and so on. Now what will be the effect of without replacement case? A draws a ball, whatever the color may be, but he or she does not replace the ball. That means now there will be 5 minus 1, 4 balls at the time of turn of B. Similarly 3 balls at the time of turn of C and D balls at the time of turn of D. A, B and C draw one ball each in turn without replacing them. One who gets a white ball first wins. The person who first draws a white ball wins the game. If it is B, then D wins the game. There will be no turn of C and D. But until one person draws a white ball, the game should be continued. One who gets a white ball first wins. Find their respective probabilities of winning. That means we require to find the probability of A winning the game, probability of B winning the game, probability of C winning the game, and probability of D winning the game. Yes, so first of all, the first case is what is the probability of A winning the game? Yes, number 1, probability A winning the game. Now the person who first draws white ball wins the game. That means if A draws a white ball, A wins the game. A starts the game, so the scenario is something like that. There are 2 white balls, 3 black balls and total 5 balls. So it is very easy to calculate the probability of A winning the game. 2C1, 1 out of 2 white balls divided by 5C1. So it is 2 by 5. Number 2. Now gradually the case will become more and more complicated. Probability of B winning the game. First of all, B's turn is dependent on A. First there is A's turn. A takes a ball. He doesn't replace that ball. If it is white, A wins the game. If it is not white, that means now there is B's turn. So B's turn is possible only if A does not win the game, or in other words, A does not say take a white ball, or in other words, A takes a black ball. Yes? Okay. So the probability will be A loses and B wins. Or A takes a black ball, or rather A fails and B wins. I will prefer the word fails. That means A draws a black ball first. That is 3C1 divided by 5C1, because when A draws the ball, all 5 balls are in the box. But now it is B's turn. A has taken his ball, he is not going to replace it. So now at the time of B's turn there are 4 balls, so total number of cases will be 4C1. But we know that A has not drawn a white ball, so all 2 white balls are there. So for B the probability will be like this: 3 by 5 into 2 by 4. means 3 by 5 into 1 by 2. So B winning the game, the probability is 3 by 10. Number 3. Probability of C winning the game. Probability of C winning the game. Now this is nothing but the logical extension of case of B. C's turn is dependent on the results of A and B. A draws a ball. If it is black, that means A fails. Now B draws a ball. If it is black, that means B fails. Then only there can be C's turn. So probability of C winning the game is ultimately probability that A fails and B fails and C wins. A fails, that means A draws a black ball, 3C1 divided by 5C1, and B fails. Now A has not replaced his ball, so total number of balls will be 4, and similarly A has drawn a black ball. He is not going to replace his ball, so now there are only 2 black balls. So B has drawn 1 black ball out of 2, and now it is C's turn. 2C1 divided by again 4 minus 1, that means 3C1, because B is also not going to replace his ball. A has not replaced, B has not replaced, so now only 3 balls are there in the box at the time of C's turn. Yes, the result is 3 by 5 into 2 by 4 into 2 by 3. We can cancel 3 and 3. We can also cancel 2's with 4. So the result is 1 by 5. So the probability C winning the game comes to 1 by 5. And the last case is probability of D winning the game. Now D's turn is dependent on the whole scenario that A fails and B fails and C fails. Then only D's turn can be there. A fails means A has drawn black ball, B has drawn black ball, C has drawn black ball, and now it is D's turn. And might well, at the time of D's turn, there are only 2 white balls, because 1 and 1, 3 black balls have been drawn by A, B and C respectively, 1 each. So at the time of D's turn, there are only 2 white balls. So definitely, if it is D's turn, D is going to win, but it is not the case of certainty. Only if A, B and C fail, then only there can be D's turn. So the probability D winning the game is probability A fails and B fails and C fails and D wins. That means A draws a black ball, 3C1 upon 5C1. He is not going to replace it. So remaining 2 black balls. B takes or rather draws a black ball out of 2 and remaining 4. Similarly, now there is only 1 black ball which C draws, 1C1 upon 4C1, and now there are 2 white balls, 2C1 upon 2C1. That means 3 by 5 into 2 by 4 into 1 by 3 into 2 by 2. Yes, cancel 3 and 3, cancel 2 and 2, cancel 2 with 4 by 2. So it is 5 into 2, 1 upon 10. The probability that D wins the game is 1 by 10. Winning the game by D becomes certainty only if A, B and C fail. I hope my explanation is helpful to you in understanding this type of problems. Okay, thank you. Good luck.